example 4 asks us to determine the number of points of intersection of each of the following graphs with the x-axis. What we want to do is just determine this without necessarily finding a solution. It's not asking us what they are, it's asking to determine the number. That is going to be dependent on the value of the discriminant of each function, of each equation here. So let's look at A. A is y equals 3x squared plus 4x minus 2. So the discriminant b squared minus 4ac is going to determine that number. If our discriminant is greater than 0, then that means that we're going to have 2 intersection points. If our discriminant equals 0, that means that we're going to have 1 intersection point, and if our discriminant is less than 0, that means that we will have 0 x-intercepts. So it's kind of tying back into section 1.1. So we need to know what our A is. So A equals 3, B equals 4, and C equals negative 2. So that means that we're going to have 4 squared minus 4 times 3 times negative 2. That's going to be 16 minus, this is 12, times negative 2 would make negative 24. So when this is a negative 24 here, if you subtract the negative, that means you're adding. So 16 plus 24 is going to be 40. So that means that we have 2 x-intercepts. Now B is y equals x squared minus 10x plus 25. So again, we need to figure out what the value of the discriminant for this equation is. And so we have A here. Oops. A is going to equal 1. B is going to equal negative 10. And C is going to equal 25. So B squared is going to be negative 10 squared. We subtract away 4 times A, which is 1, times C, which is 25. So negative 10 squared is 100. And we have 4 times 1 is 4, times 25 is 100. And that's going to equal 0. So this is an equation that has a discriminant of 0. That means that it has only one real solution. It's a double root. So it's technically 2 solutions that are the same. But 2 solutions that are the same, when we talk about graphs, that means that it's only going to have 1 x-intercept. So while a double root is 2 separate solutions, that is 2 separate solutions, but when we talk about graphs, it only appears to be touching once, because that's what it looks like, but it's 2 separate, or 2 of the same solutions. Now the last one is y equals negative 2x squared plus x minus 7. So we're going to do the same process again. So we need to figure out our A is negative 2, B equals 1, and C equals negative 7. So B squared is going to be 1 squared. We're subtracting away 4 times A, which is negative 2, and C, which is negative 7. So 1 squared is 1. Then we have 4 times negative 2 is negative 8. Negative 8 times negative 7 makes positive, negative 8 times negative 7 makes 56, or negative 56. So we subtract away 56. This is going to make negative 55. So this is a negative discriminant, which means that we have two non-real solutions. Non-real solutions, we don't see that on a graph. We can't see where those are. So this equation has 0 x-intercepts. So by looking and analyzing the discriminant of a quadratic function, we can determine not only the nature of the roots, but we can determine the number of x-intercepts.